we're going to learn today. Before we learn those specific rules, though, we are going to review just what exponents are. So if I take an example like 2 raised to the 5th power, remember 2 is representative of your base, so that larger number will be your base, and then that itty bitty guy is your exponent. So we say this is 2 raised to the 5th power. The exponent tells us how many times we're going to multiply the base. So since our exponent is 5, that means we're going to multiply 2 by itself 5 times. So we're going to have 2 times 2 times 2 times 2 times 2. So 2 to the 5th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. The first rule that we're going to look at today is called the zero exponent property. What it says is for any non-zero number A, so 1, 2, 3, 4, -1, -2, -3, any number but 0, when we raise it to the 0 power, the answer is always 1. So any value that is raised to the 0 power is 1. 4 raised to the 0 power is 1. -6 raised to the 0 power is 1. This one's slightly different because the 0 is touching only the 5. So 5 raised to the 0 power is 1, but that negative out in front makes our final answer -1. Why is this? Why would anything that's raised to the 0 power be 1? So we're going to work backwards to get to this idea. So we just said that 2 to the 5th power was 32. 2 to the 4th power, if we recall, is 16. We're going backwards. 2 to the 3rd power is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. If we look at it in descending order, if we're going from one value to the next, we're taking out a power of 2, which means every step that I go down, so from the 5th to the 4th power, I'm dividing out by 2. From the 4th to the 3rd power, I'm dividing by 2 to get the next answer. From the 3rd to the 2nd, dividing by 2. From the 2nd to the 1st, I'm dividing by 2 because I'm taking out a power of 2. So this continues when we go into the value of 0, and then even when we go into negative exponents. So when I'm going from the 1st to the 0 power, I'm taking out a power of 2 by dividing by 2. And 2 dividing by 2 is 1. This is true for any number. 3 to the 3rd power is 27. 3 to the 2nd power is 9. 3 to the 1st power is 3. So when I'm going from one power down to the next, when I'm taking out that factor of 3, I'm dividing by 3. 27 divided by 3 gives me 9. 9 divided by 3 gives me 3. 3 divided by 3 gives me that answer of 1. That is the reason why, okay, the easiest thing to remember is if you're raising something to the 0 power, whatever that number may be, your answer is always 1. Our second property is dealing with negative exponents. And this is going to kind of piggyback onto that 0 property rule. For any integer n and any non-zero number a, if we take that any number to a negative power, we are actually taking the reciprocal. So a very common misconception for students is they see something like 4 to the negative 2nd power, and they think 4 times 4 is 16, So 4 to the negative second power must be negative 16. That is false. Negative exponents create a fraction, not a negative value. So when we're looking at something like 4 to the negative second power, we're really taking its reciprocal, which is 1 over 4 squared, or 1/16. 3 to the negative third power, we're going to take the reciprocal, 1 over 3 to the third power, or 1 over 27. If the negative exponent happens to start on the denominator, we still take the reciprocal. So 1 over 5 to the negative second becomes 5 to the second power over 1, which is just 25. Why is this? So we just went through our power rules. So if we have 2 to the third power, that is 8. 2 to the second we know is 4. 2 to the first is 2. We now know that 2 to the 0 power is 1 because anything to the 0 power is 1. So it follows that same concept. When we take out a factor of 2, we're dividing by 2 to go from one factor down to the next. So if I'm at 2 to the 0 power and I'm going down to the negative first power, I'm dividing by 2. 1 divided by 2 is a half. When I'm going down to the negative second power, I'm taking out a factor of 2. So half of a half, or a half divided by 2, is 1/4. When I go down a power, so I'm going to the negative third power, I divide by 2 again. 1/4 divided by 2 is 1/8. And if you notice, 2 to the third power is 8. 2 to the negative third power is just the reciprocal, 1 over 8. 2 to the second power is 4. 2 to the negative second power is the reciprocal, 1/4. 2 to the first power is 2. 2 to the negative first power is the reciprocal, 1 over 2. The third rule we're going to look at is the product of powers property. So in simplest form, what this is saying is when you are multiplying powers with the same base, all you have to do is add the exponents. So our first example, we're multiplying the same base of a to the 5th times a to the 6th. So we add together the exponents. 5 plus 6 is 11. So a to the 5th times a to the 6th is a to the 11th power. B to the negative 6th times b to the 3rd, so once again, same base. So we can add the exponents of negative 6 plus 3, which is negative 3. It is like a math sin to write negative exponents, though, so we're always going to have to rewrite. So I'm going to take b to the negative 3rd power. Since we do not like negative exponents, I take the reciprocal, so my final answer is 1 over b to the positive 3rd power. Why is this true? So if we expand out exponents, expand our bases like we normally do, I can rewrite a to the 3rd power as a times a times a, 3 a's. I'm multiplying that by a to the 4th power. So I expand a to the 4th power, or a, 4 times. If I want to join these together and write it as just one single base, I just count how many a's I have. So I have 3 a's plus 4 a's. There's a base of a, and there's a total of 7 of them. So that's why we can shortcut it and just add the exponents together. Our fourth rule is the quotient rule. So when we multiply, we add the exponents together. When we divide the powers with the same exact base, this time we're going to subtract. So we have common base of a to the fifth power divided by a to the second. When we divide, we subtract the exponents. 5 minus 2 is 3. So it simplifies down to a to the third power. A negative example, if we have common base of b to the second divided by b to the seventh, we subtract 2 minus 7, which gives us negative 5. We talked about how it's a math sin to write a negative exponent, so I'm going to take the reciprocal to get 1 over b to the fifth. Why does this work? So if I go and I expand each of my bases out, so I take x to the sixth power and I expand it 6 times, and I'm going to divide that by x to the second power, so I'm going to expand that x 2 times. Well, when we divide anything by itself, so like 5 divided by 5 makes 1, x divided by x is 1, they kind of negate each other. So 1 pair of x's, 2 pair of x's, that essentially become 1. So it's 1 times all those x's, but 1 times 1 is just 1. Then we are left with 4 leftover x's, which is why 6 minus 2 we can shortcut to give us x to the fourth power. Our last property that we're going to learn today is a power of a power property. So this means when we are raising a power to a second power, we're going to multiply those exponents together. So I am raising a to the eighth. Let's backtrack. That's a little bit hard to start with. So let's start with a to the third raised to the second. So when we have a power raised to a power, so here's my exponent raised to another exponent, we multiply them together. So 3 times 2 is 6. So now if we look at our first example, if I have a to the eighth and b to the first, I'm raising them both to the third power. So 8 times 3 gives me 24. 3 times that imaginary number gives me 3. We can't do anything else with these guys because they are different bases. So why does that work? So we're going to do a double expansion. So the first expansion says that I have 4 sets of y to the third. So 1, 2, 3, 4. Now we could stop here and go back to our multiplying powers with the same base. So we have the same base of y. And then if we have the same base, we just add those exponents together. 3 plus 3 plus 3 plus 3 is 12. So that's why we're allowed to just simply multiply them together. So what are your examples going to look like? Remember, we are not going to write any negative exponents. So all of your instructions or directions are just going to be to simplify. So we have to keep all these rules intact. So a couple things to look at. For example, A, we have x to the 0 power, and we are also looking at y to the negative third power. So let's tackle the first. So x to the 0 power, any number to the 0 power is 1. And we don't like negative exponents, so we're going to have to take the reciprocal of y to the negative third power, which means it's going to move from the denominator up to the numerator. So 4 times 1 is 4, and then times y to the third power, which will be our final answer. Example B is dealing with our third rule, multiplying exponents with the same base. So I'm kind of playing a matching game. I have regular coefficients of 2 and -6, bases of A, and bases of B. So, starting with my coefficients, 2 times -6 is -12. A to the 5th times A to the 3rd, our shortcut is to add. So 5 plus 3 is 8. For my base of B, I'm going to add -3 and an imaginary 1. -3 plus 1 is -2. Remember our math sin, we do not like negative exponents. Recall or notice that I didn't say negative coefficients. Those are okay. We don't like negative exponents, so we're going to transfer that from the numerator down to the denominator. So my final answer is -12a to the 8th over b to the 2nd. Example 3, we're dealing with our division rule. So we're going to subtract the exponents. Once again, we're going to pair up. So we have normal coefficients. Then we have a base of x and a base of y. So we're going to take it one pair at a time. 3 over 6 reduces to 1/2. For my x values, 2 minus 7 is -5. For my y values, 9 minus 5 is 4. We do not like negative exponents though, so I am going to transfer x down to the denominator. So my final answer is y to the 4th up top, 2x to the 5th on the bottom. Our last rule is a power raised to a power. So I'm going to share, just like the distributive property, I'm going to take every value, the coefficient, the w, and the y to the 2nd power. So -5 squared is -5 times -5, which is 25. Power raised to a power, our shortcut is to multiply. So w is going to be to the 6th power, and y is going to be to the -4th power. However, we do not like negative exponents, so I'm going to transfer from the numerator down to the denominator. So my final answer is 25w to the 6th, y to the 4th. You're going to practice with these rules individually. It is on the back side of your sheet. And then we're going to practice with this tomorrow to make sure that you know it as well and you're comfortable with it.